Hi everyone, and welcome to today's video. We're going to be diving into how computers manage memory, specifically RAM, ROM, and virtual memory. Think of this like uncovering how your computer's brain works. So by the end, you'll understand why your laptop slows down when you have too many tabs open, how it starts up when you press the power button, and why memory is so crucial to performance. Let's get started. So here's what we'll cover first. So why computers need primary storage? The working memory that keeps everything running smoothly. Then we'll compare RAM and ROM, how they're different and what they're used for. Finally, we'll tackle virtual memory, the trick your computer uses when it runs out of space. Stick around because this stuff matters, and whether you're gaming, coding, or just binge watching videos. So just a quick question to kick things off. What are 4 types of memory in a computer? Pause and think. I'll give you the answers in just a moment. First, CPU registers, tiny but lightning fast storage inside the processor. Next is cache, a small, speedy memory that helps the CPU. Then we have RAM and ROM. The two we'll focus on today. And bonus, the virtual memory, which we'll explain later. If you've ever wondered why your computer struggles with 50 Chrome tabs, RAM is the culprit. So what is primary storage? Well, primary storage is like your computer's workspace. It holds data and programs that are actively in use, similar to how your desk has books and notes you're working on right now. Without it, your CPU would have to dig through your hard drive for every tiny task, which would be painfully slow. The two main types are RAM and ROM. RAM is your multitasking buddy, while ROM is a computer's instruction manual that never gets erased. RAM, or random access memory, is your computer's short-term memory. It's where everything you're actually using lives. Your open apps, your half-finished essay, even the operating system. The random access part means the CPU can grab any piece of data just as fast as any other, so there's no waiting. But here's the catch. RAM is volatile. Turn off the computer and everything vanishes. Imagine writing on a whiteboard during class. It's useful, but wipe it clean at the end of the day and it's all gone. When you power on your computer, RAM starts empty. First, it loads the operating system, like Windows or Mac OS. Then, every program you open, say Spotify or Photoshop, gets copied from the hard drive into RAM. Even the files you're editing sit here temporarily. Think of RAM like a chef's countertop. The ingredients are like the data, and the tools are like the programs. They all need to be within arm's reach to work efficiently. The bigger your countertop, or RAM, the more you can do at once. But what happens when RAM runs out of space? Say you've got Chrome, Word, and a game open, and your RAM is full. Your computer doesn't just crash. It uses a clever trick called virtual memory. It takes less urgent data from RAM, like a background tab you haven't touched in hours, and moves it to the hard drive. It's like storing extra kitchen tools in the basement. You can still get them, but it will slow you down. Virtual memory is basically fake RAM on your hard drive. The upside is that it's cheap and prevents crashes. The downside is that hard drives are snails compared to RAM. Imagine your computer is constantly shuffling data between RAM and virtual memory, like a librarian running between the main library and the storage warehouse. That's why your PC feels sluggish when you've got too much open. More RAM means less reliance on this slow backup. ROM, or read-only memory, is the computer's permanent instruction manual. Unlike RAM, it's non-volatile. It keeps its data even when the power is switched off. You can't edit RAM, it's hardwired. It's hardwired at the factory. It's like the ignition system in a car, always there to start the engine, no matter how long it's been parked. So what's stored in RAM? What's stored in ROM? Well, ROM stores two critical things. The bootstrap program, which tells the computer where to find the operating system on the hard drive, and the BIOS, which controls basic hardware settings like CPU speed. And here's a fun fact: ROM works even if your hard drive fails. That's how your computer can still show an error message like no operating system found. Let's compare RAM and ROM side by side. RAM is volatile. ROM isn't. RAM is read and write. ROM is read only. RAM is fast, but it's expensive. ROM is slower, but it's also cheaper. RAM handles running programs. ROM handles startup. Think of RAM as a whiteboard and ROM as a textbook. One's for temporary work, the other for permanent reference. Memory speeds vary wildly. Fastest are CPU registers, tiny but instant. Then we have cache, slightly bigger but still speedy. RAM is next, much larger but slower in comparison. ROM is slower still, and virtual memory on the hard drive is the slowest. Picture this like a library. Registers are the books in your hand. Cache is the shelf next to you. RAM is the library itself, and the hard drive is a warehouse across town. Modern PCs usually have 8 to 32 gig of RAM. They will probably go up to 64 gigs also. But why does this matter? More RAM means more programs can run smoothly. A phone with 4 GB might choke with 20 apps open, while a gaming PC with a 32 GB barely breaks a sweat. It's like having a bigger desk, more space to spread out your work. Time to test your knowledge. Pause and have a go at answering these questions. So, what does RAM stand for? Why doesn't ROM lose data when powered off? Why is virtual memory slower than RAM? So RAM stands for random access memory. It's non-volatile. Hard drives are slower than RAM So to recap, RAM is your computer's fast, temporary workspace. ROM is its permanent startup guide. Virtual memory is a slow but life-saving backup. So understanding this helps you troubleshoot, like why adding more RAM speeds up your computer. If this video helped, hit like and subscribe for more tech breakdowns. Thanks for watching and see you next time.